Students, I welcome you for the second lecture on the testing of materials. So in the previous class, we stopped up to the different types of material testing process. I discussed why we are using destructive as well as non-destructive testing. So it's based on case-to-case basis. So destructive testing is used where we need exhaustive test of the material properties. For example, tensile strength, compressive strength, hardness. These things can be tested by doing some damage to the material. For example, if you have to test the hardness of material, you have to push it to the limit of hardness. Then only you can find the properties. Whereas non-destructive testing, it involves checking whether there are cracks, what are the composition of material available. So what's the surface finish of the material, or roughness of the material. So these properties can be tested using non-destructive methods without damaging the material. So that's the main difference between these two. So in our particular course, we will be studying only about the destructive testing. So why are materials tested? Our next point. So first one is to ensure the quality, to make sure that the material is up to the standard which we have set. For example, after designing the engine, you would have some predefined qualities required. It should withstand this much amount of heat. It should withstand the torque produced. So like this, also it should be able to withstand the compression inside the combustion inside the cylinder. So you have to test whether the material we have selected will be able to withstand these tests. So that's the first thing. And then to prevent failure in use. So when you are using the material repeatedly for 10, 20 years, say for hundreds and thousands of cycles, the piston cylinder will be moving in tandem. So there should be able to withstand that much amount of load for prolonged period of time. So that has to be ensured. So to do these things, we are going for the testing of materials. So another thing is, once you determine the material is safe to use, you have to set a value called as factor of safety. So factor of safety, as we all know, factor is nothing but division of two values. It's a ratio of two values. So here factor of safety, actually what it means is that the strength for which, for example, the strength for which we have designed versus the strength which is actually needed. So let me explain it with a simple case. Imagine we will be using our chair every day, plastic chair we are using. So normally a plastic chair would be able to we can say that a plastic chair need to withstand a weight up to 150 kg. We can say a 150 kg. A normal human would be in the range of 150 to 100 kgs. Normally everyone would come in at this range. So if you are designing a chair, if you are designing it for only to withstand a load of 100 kgs, so is it possible, practically possible, to use the chair for everyday use? So imagine you are having kids in your home. So they would come and sit in your lap. And also not everyone would be of the same weight category. So it is practically impossible to design a chair for the required weight alone. 100 kg, if you design it, it is not practically suitable because it may break and it may lead to the failure of your product. So what you will do is, you will design a chair so that it withstands 200 kgs. Up to 200 kg, a normal chair may withstand. So that extra limit, if you divide the limit for which you have designed for 200 kg by the actual load which is needed, 100 kg, then if you divide those two, 200 by 100, 2. So the factor of safety here is 2. So that is what factor of safety means. You will be always providing some factor, some extra load bearing capacity. So that is to prevent the failure of material during your use. Intended use, it should remain functional. So that's called as factor of safety. Any material which we design will have this factor of safety. So a question to you, factor of safety, what determines the factor of safety? So if we are using material with high cost, then what will be the factor of safety? Will you be setting higher factor of safety or lower factor of safety? So discuss among yourself and come with the solution while you're coming to the next lecture. Thank you.